Algebra 1 EOC Review Part 2 Exponential Functions. What do exponential functions look like? Exponential functions are written in this form: y equals ab to the x power plus c. The first thing I want to point out is that in an exponential function, the exponent is always a variable. Again, in an exponential function, the exponent is always a variable. Here I have several examples of different exponential functions, and on the bottom it's asking you to input a value into the function and get the answer. So let's look at this example first of all. In this example, on the top they give us the function f of x equals negative 2 times 11 to the x power minus 8. And you got to find f of 1. Alright, so remember, in functions, that means that you're going to input the 1 into the function, and wherever you see the variable x, you got to substitute x with that number 1. So to find f of 1, you're going to do negative 2 times 11 to the first power minus 8. Now you always follow the order of operations, which means first you do the exponent, then you multiply, and then you subtract. So 11 to the first power is 11. 11 times 2 is negative 22. And negative 22 minus 8 is negative 30. So f of 1 is negative 30 in this example. Okay, same thing over here. Here they want us to find f of 0. So f of 0 means you're going to do 7 times 2 to the 0 power plus 8. Again, follow always the order of operations. Now you got to remember, any number to the 0 power always equals 1. Again, any number to the 0 power always equals 1. So 2 to the 0 power is 1. 1 times 7 is 7. And 7 plus 8 is 15. So in this example, f of 0 equals 15. Over here, they give us the exponential function on the top. F of x equals 9x minus 7. They want us to find f of 2. So you plug in the 2 where the x is. Do 9 to the second power, which is 81, minus 7. Okay, now notice that in this one, okay, if I write this function underneath my formula or my exponential function form here, I would have f of x equals 9 to the x power minus 7. So C is the negative 7, B is 9, what is A? If there's no number written here, that means A is just an invisible 1. Alright, you got to realize things like that because we're going to need them in the examples coming up, okay? Same thing, like for example right here on this last one, they give us this function. That's an exponential function, right? You got to realize that in this example, C is an invisible 0 and A is an invisible 1. So it is written in the correct form of an exponential function. It's just that A, you don't see it because it's an invisible 1, and C, you don't see it because it's a 0. You don't write those, okay? Because your information should always be simplified. Okay, así que una función exponencial se escribe en esta forma. Ok, aquí tengo diferentes ejemplos de funciones exponencial donde tienen que encontrar la respuesta cuando entran el valor que está dentro de paréntesis. Recuerden que un exponente de 0, un número con un exponente de 0 siempre te da 1. Por ejemplo, aquí la función dice f de x igual a 6 a la x. Así que, ¿qué sería f a la 0? Si pongo el 0 donde está x, 6 a la 0 te da 1. Cualquier número con un exponente de 0 siempre te da 1. Y se tiene que dar cuenta si falta, por ejemplo, aquí, ¿ok? Parece que no hay un número al frente del 9, pero se tiene que dar cuenta que eso es porque A es un 1 que no se escribe. Y en este ejemplo aquí, si lo escribo debajo de la forma y igual a b a la x más c, ¿ok? No hay ningún número aquí atrás porque he entendido que es un 0 invisible. Y para a tampoco hay un número escrito aquí porque he entendido que hay un 1 invisible, ¿ok? Porque no se escribe. Okay, moving on. All right, so in exponential functions, when you analyze the y values, they're being multiplied over and over again by the same number. If you saw my video on linear functions, I said that in linear functions, the y values are being added over and over again by the same number. In exponential functions, they're being multiplied over and over again by the same number. So right here in this example, all the y values are being multiplied by 3. In this example also, they're all being multiplied by 3. In this example, they're all being multiplied by 2. In this example, notice the numbers are going down. All the numbers are being divided by 3 over and over again, which means they're being multiplied by 1 over 3 over and over again. Okay, so realize, let me rephrase what I said. In exponential functions, the y values are either being multiplied or divided over and over again by the same number, multiplication or division. Just realize that if it's being divided over and over again by the same number, you could write that as a fraction and multiplication. So dividing by 3 over and over again is the same as multiplying by 1 over 3. Here they're all being multiplied by 3. Here we have fractions, and you could see that they're going from 20 over 3 to 40 over 9. So you got to realize that the top is being multiplied by 2 and the bottom is being multiplied by 3 to get 40 over 9. So each y value is being multiplied by 2 over 3 to get the next one. Okay, so again, an exponential function, the y values are being multiplied or divided over and over again by the same number. A linear function, which I did in another video, the y values are being added over and over again by the same number. Let me say that better. In a linear function, the y values, you're adding the same number over and over again to the y values, or subtracting the same number over and over again. Ok, así que en una función exponencial, los valores de y se están multiplicando o dividiendo por el mismo número cada vez. Así que, por ejemplo, en esta tabla, los valores de y se están multiplicando por 3 cada vez. Y aquí también por 3. Aquí se están multiplicando por 2. Aquí están dividiendo por 3 cada vez, que es lo mismo que multiplicando por 1 sobre 3. Aquí están multiplicando por 3 cada vez. Aquí tenemos fracciones que si analizan por cuánto se multiplica 20 sobre 3 para coger 40 sobre 9, se multiplica por 2 sobre 3. Ok, así que en una función exponencial los valores de y se están multiplicando o dividiendo por el mismo número cada vez. Okay, now, I know this looks complicated. If you listen to me, it's not, okay? So let's talk about the graphs of exponential functions. This is important, and I'm telling you, if you pay attention, I'm going to break down how you can look at this and make sense of it, and it's actually not difficult at all. Okay, so let's talk about A, B, and C a second. First, let's start with C. Okay, it says it right here that in the graph of an exponential function with the equation y equals ab to the x power plus c has the following properties. Okay, it has a horizontal asymptote at y equals c. All right, what does that mean? Look at this graph and I'll explain. An asymptote is this line right here. And what that is the graph of this line, as we go to the left, it's getting closer and closer to the line y equals -5. It's getting closer and closer to this line, but it will never reach it. Mathematically, it will never reach it. It keeps going into infinity forever, getting by minuscule amounts, getting closer and closer to y equals -5, but it will never reach it. That is what an asymptote is. This imaginary line that the graph of this line keeps getting closer and closer to, but will never reach it. All right. So if you look at these examples here, the asymptote in all of these is the x-axis. But in the next couple slides, I'll show you examples where the asymptote is a different line, not the x-axis. All right. I need to point that out so that I can explain some other things. Okay. Okay. Now let's talk about A. Okay, if you look at the graphs here, okay, on the top two graphs, it says that if A is positive, if A is greater than 0, that means when A is positive. So when A is positive, the graph of the line is above the horizontal asymptote. And when A is negative, the graph of the line is beneath or below the horizontal asymptote. So again, the top ones, A is positive. You could also look right here at this example. A is positive, so the graph of the line is above the horizontal asymptote. On the bottom ones, A is negative, so the graph of the line is below the horizontal asymptote. Okay, and then the last thing is B. Let's talk about B. If B is a number greater than 1, okay, the line will be going away from the horizontal asymptote from left to right. And if B is between 0 and 1, if B is between 0 and 1, the line will be going towards the horizontal asymptote from left to right. So same thing down here. Okay, if B is greater than 1, the line is going away from the horizontal asymptote from left to right. And if B is between 0 and 1, it's going to be heading towards the horizontal asymptote from left to right. Okay, let me say that in Spanish. Okay, así que en español, el número que está aquí, donde está la C, se le llama en inglés un asymptote. Es una línea horizontal imaginaria que el gráfico de esta línea se está acercando, pero nunca llega a tocar esa línea imaginaria. ¿Ok? Así que eso, el número que está aquí te dice dónde que queda el asymptote. Si A es un número positivo, ¿ok? Como los dos gráficos aquí arriba, el gráfico de la línea está arriba del asymptote horizontal. Y si A es un número negativo, como en los dos ejemplos aquí abajo, entonces el gráfico de la línea estaría debajo del asymptote, que es esta línea horizontal. Y B, si B es un número más grande que 1, entonces el gráfico de la línea de izquierda a derecha se va alejándose del asymptote. ¿Ok? Igual que aquí. Si ve un número más grande que 1, de izquierda a derecha el gráfico de la línea se va alejándose del asymptote. Y si B es un número entre 0 y 1, entonces el gráfico de la línea se va acercándose al asymptote de izquierda a derecha. Vamos a mirar algunos ejemplos para que vean qué fácil es. Okay, so actually hold on this graph. Okay, so let's look at some examples of graphs here. Okay, which equation matches this graph? Okay, so look at my horizontal asymptote. It's at positive 2. All right, so in my equation for that graph, the C has to be plus 2. So my answer would be between one of these two. Now, if the graph is below the horizontal asymptote, that means A has to be negative. And the graph of the line is going from left to right, away from the horizontal asymptote, so B has to be greater than 1. So this would be my answer here. Okay, if we look at this example, and by the way, try to just get a general idea, because we're going to look at word problems in a second, and hopefully after a few examples, it'll start to make more sense. All right, so right here, look at my horizontal asymptote. It's located at 6. All right, so the number in the back of my answer has to be plus 6. The graph of the line is above the horizontal asymptote, so A has to be a positive number. So it's got to be this answer. But also notice that B, since from left to right, the line is going away from the horizontal asymptote, B has to be greater than 1. All right, so this is my answer. I got this from IXL. I'm just doing it to give you a general idea of how to remember if A is positive or negative, what happens if B is greater than 1. We're going to look at some more different examples in a second, okay? So over here, look at my horizontal asymptote. It's located at negative 5. So my C has to be negative 5. It's either this one or this one. The graph of the line is below the horizontal asymptote, so A has to be negative. Both of these have a negative A as well. Now from left to right, the graph is getting closer to the horizontal asymptote. Okay, that means that b has to be a number between 0 and 1. Okay, so this would be my answer right here. Okay, and then let's look at these. Wait, are these the same ones? Yeah. All right. So let me look at two more examples, and then I'll go to the word problems. Okay. Now, again, the horizontal asymptote is indicated by that number right there. So first, I look which graph has a horizontal asymptote at positive 2. There's only one, which is this one, because this one's at positive 1. But let's just keep studying this a second. All right. So what is a in this example? All right, remember an exponential function is written in that form. Okay, so what is a in this example? A has to be negative 1 because b is 1 over 4 to the x power. Okay, so since a is negative, that means the graph of the line is below the horizontal asymptote. And since b is a number between 0 and 1, that means from left to right, the graph of the line is getting closer to the asymptote, to the horizontal asymptote. Over here, c is negative 1. So all four of these examples have a horizontal asymptote at negative 1. Okay, now a is negative, so that means that the graph of the line has to be below the horizontal asymptote. So it's got to be one of these two down here. Okay, now b is greater than 1, so that means that from left to right, the graph of the line is going to get closer to the horizontal asymptote. So this is my correct graph, okay? Hopefully that's giving you an idea of how to graph these, all right? Now, let's go back to the slide I skipped, which is this one. Okay, now, this I'm going over and we're going to apply it to word problems. So, if by any chance you weren't understanding too good the other parts, this part is really important, okay? So look, exponential growth and decay has to do with just these two graphs right here. In both of these graphs, all of these examples, a is a positive number. A is a positive number in all of these. Okay, now exponential growth is when b is greater than 1. If b is greater than 1, you're going to have exponential growth. And if b is between 0 and 1, you're going to have exponential decay going like this. Okay? This is only for these examples where a is positive, which is going to be the case when we look at the word problems that we're going to do in a second. And these are the type of a lot of the questions on the exam is going to be like this, are about this stuff, all right? So si b es un número más grande que 1, está aumentando exponencialmente la línea o la situación, porque en un momento vamos a ver problemas con palabras y con situaciones, así que para que entiendan. Y si b es un número entre 0 y 1, está disminuyendo, okay? All right, so look, this, let me explain something. This is the same thing we were just looking at, but it's further breaking down something about b for word problems. All right, so for word problems, this is like the key right here, and I'm telling you, when I demonstrate, it'll make a lot of sense. All right, for word problems, the initial amount is always going to be a. The rate of growth or decay is going to be r, and you're either going to add it or subtract it to 1. If it's growth, you're going to add it. If it's decay, you're going to subtract it. You'll see what I mean. And the number of periods is the number of time periods is t. All right. Again, stay with me. Give me 1 second. Once you see the examples, it'll all make sense. And I'll keep referring back to this formula. Esta fórmula es lo más importante para ahora hacer los problemas que son con palabras y con situaciones que tenemos que traducir a una función exponencial. Luce complicado, pero cuando vean los ejemplos creo que lo van a entender. Lo que quiero que se den cuenta es que A siempre es la cantidad inicial. R siempre es el rato de crecimiento o que está disminuyendo. Okay, y T es los periodos de tiempo. All right, so look. I put several examples of exponential growth and several examples of exponential decay. Look and you'll see what I mean, okay? First of all, in my first sentence, there are 150 rare tigers. Boom, that's my initial amount, 150. Right here, forget about the rest. I'll get to the rest in a second. Miguel deposits $500 into a bank account. $500 is my initial amount. Samantha buys a $200,000 house. $200,000 is my initial amount. A plant is 20 inches tall. 20 is my initial amount. Let's keep going. Down here, well, down here the examples are similar. But you get what I'm saying, all right? A is always the initial amount. That's super important. A is always the initial amount. You're going to have a lot of questions like this on the exam, so this is important. All right. A siempre es la cantidad inicial. Okay. Así que en cada situación aquí, miren, aquí hay 150 tigres. Eso es mi cantidad inicial. Miguel pone $500 en una cuenta del banco. Así que esa es la cantidad inicial. Ok. Todo esto son la cantidad inicial, así que lo pongo donde va A. Alright, sorry guys, it's too much on my mind and I'm making this video late and I'm trying to hurry up. Alright, okay, now let's look at the second part. Okay, now this is key, so please pay attention. The B, alright? It says here the population is increasing by 20%. There's two ways you can think about it, alright? One way you could think about it is you change 20% to a decimal, which would be that, and you add it to 1. So you get 1.20. Or another way to think about it, which you may find it easier, is this. The population is increasing by 20%. Add that to 100%. You get 120%. And then change 120% to a decimal, which would be 1.20. Let's do another one. The bank account earns 8% interest each year. So 100% plus 8% is 108%. And you write that as a decimal, it would be 1.08 because you move the decimal point 2 times to the left. The house that Samantha bought, its value appreciates. That means it goes up by 15% each year. 100% plus 15% is 115%. And then you move the decimal point 2 times to the left. A plant is 20 inches tall and it is growing at a rate of 5% per month. 100% plus 5% is 105%. And then move the decimal point 2 times to the left, you get 1.05. That is the way you set up these equations. All right. Once you set it up correctly, you use your calculator for everything else. Okay. And when it's going down, when the value is going down, like here it's decreasing by 20%, you got to subtract that from 100%. So 100% minus 20% equals 80%. 80% as a decimal is 0.80, which is what's here. All right. Here it's depreciating by 3%. That means going down by 3%. 100% minus 3%. Sorry. 100% minus 3% is 97%. 97% as a decimal is 0.97. All right. A house whose value depreciates by 15% each year. 100% minus 15% is 85%. 85% as a decimal is 0.85. Okay, this man is losing weight at a rate of 8% each year. 100% minus 8% is 92%. 92% as a decimal is 0.92. All right. Again, if you understand that, it makes it very easy to do word problems involving exponential growth and decay, which is what you're going to have. Okay. Así que para B, okay, pueden pensar de esto de dos maneras. Okay. En este ejemplo está diciendo que está aumentando por 20%. Así que pueden pensar, número uno, se cambia 20% a un decimal, moviendo el punto decimal 2 veces a la izquierda y se le suma a 1, que te daría 1.20, que es lo que escribo aquí. Pero creo que es más fácil si piensan 100% más 20% te da 120% y cambio 120% a un decimal que sería 1.20, moviendo el punto decimal 2 veces a la izquierda. Y cuando está disminuyendo, se le resta este porcentaje a 100%. Así que en este ejemplo, resto 100%, 100% menos 20%, que te daría 80%, y se escribe 80%, 0.80. ¿Qué es lo que está escrito aquí? Etc. All right, so now we're into the examples of the type of questions that are on the Algebra 1 EOC. It says, which of the following scenarios gives reasonable interpretations of what 1 plus 0.05 to the t power in that expression means? Okay, so look at the different answer choices and keep in mind that just like we were just going over, A is the initial amount and B represents the growth or the decay. All right. In this case, it's growth because you're adding that number to 1. All right. So this is exponential growth. All right. So one of the correct answers says a snake is 250 millimeters long. It increases in length by 5% every week. After t weeks, the snake will be 1 plus 0.05 to the t power times longer. Yeah, that one's correct. And the last one is also correct. An empty water tank is partially filled with 250 gallons, and the volume of water in the tank increases by 5% each month afterward. After t months, the number of gallons will be increased by a factor of 1 plus 0.05 to the t power. All right. Make sure you look at the wrong answers as well. Okay. You could pause the video and look at that, but let me continue going so that we could speed this up. All right, and again, let's. All right, this one says a bacteria culture starts with 3 cells, so that's the initial amount right here, 3. Each cell in this culture doubles every hour. After t hours, the number of cells in the culture can be written as 3 times 2 to the t power. Interpret the meaning of 2 to the t power in this context. Okay, so A is wrong because it says that that's the initial number of cells. No, 3 is the initial number of cells. The factor 2 to the t power is the number of hours. No, t is the number of hours. So that one's wrong as well. The factor 2 to the t power is the number of cells in the culture after t hours. No, the number of cells in the culture, you'd have to multiply that times 3. So the last one says the factor 2 to the t power is the number of cells that each original cell in the culture has produced after t hours. Yeah, D is the correct answer. All right, D is the correct answer. All right, but look again how just understanding that A is the initial amount and B is the growth or the decay can help you answer these word problems. Which of these functions describes exponential growth? Okay, so again, exponential growth are the functions where b is a number greater than 1. So with that in mind, in our first example, is b greater than 1? Yes, it is, because keep in mind that a is an invisible 1 and b is 1.25 to the t power. All right, remember, this is the form for exponential functions. If there's nothing written here, it's understood there's an invisible 0. All right, so b is a number greater than 1. So yes, this is exponential growth. This one is less than 1. It's decay. This one is greater than 1. All right. Si b es un número más grande que 1, eso es crecimiento exponencial. All right, so this one is correct. This one is decay. This one is growth. All right. Again, if there's only one number written, that means that A is a 1, an invisible 1. Si solamente hay un número escrito, eso quiere decir que A es un 1 invisible. All right, so there are the correct answers. They give you this function that models Joanna's annual earnings. Which of the following statements are true about Joanna's salary? Okay, so as you can see, 44,000 is how much she initially earns. Okay, she does not initially earn 45,000. Joanna's salary increases by 1.045% each year. No, that percentage is written wrong. Okay, the percentage would be, you got to move the decimal point 2 times to the right. So her percentage is actually increasing by four. Be careful with this one. Her salary is increasing by 4.5% each year. Okay, because you're adding 4.5% to the to what she already makes. All right, so 100% of what she makes is what she already makes. But if you add 4.5% to it, you would get 104.5%. So her salary is increasing by 4.5% each year because that's what you added to the 1 or to the 100%. So those are the only two correct answers there. Be careful with that one in the way that you think about it. I mean, because it's easy to mistakenly pick this one that says that her salary is increasing by 104.5% each year. It's increasing by 4.5% each year. Okay. El salario de Joana está aumentando por 4.5% cada año. Tengan cuidado no escoger esta que dice que está aumentando por 104.5% cada año. Porque lo que están sumando a el 1 es 4.5%. Okay, so which equation represents this function, okay? Well, first of all, let me tell you, one way you could do it is just by substituting these values for x, okay, and seeing if they give you the y values that are there. That would probably be the quickest way to do it, to be honest with you. So, for example, if x is 3, 3 to the third power is not 9. 3 to the third power is 27. So this cannot be the answer. If x is 3, 3 times 3 is 9, but 4 times 3 is not 17. So that can't be the answer. If you put 3 in this function, 2 to the third power is 8. 8 plus 1 is 9, so that works. 2 to the fourth power is 16. 16 plus 1 is 17. That one works. All right, it looks like this is the answer. Let me just check D real quick. 2 times 3 is 6. 6 plus 3 is 9. 2 times 4 is 8. 8 plus 3 is 11. So basically, if you just substitute, I think that's the quickest way to do this one. Substitute the values for x and see what you get for y. So like when x is 3, do you get f of x equals 9? When x is 4, do you get f of x equals 17? That would be the easiest way to do this one, okay? La manera más fácil de hacer este problema es sustituir los valores para x dentro de las funciones para ver si te dan la misma respuesta que está aquí para f de x. Okay? Esta es la única que trabaja para esta tabla de valores. Alright, so by the way, that was the answer, letter B. Okay, so Marcelo is tiling his kitchen floor with 45 square tiles. The tiles come in whole number side lengths of 6 to 12. There's this function. What is the domain of this function? All right. It says S. The domain is the values for S, okay? S is the side length of the tile. And it says that the tiles come in whole number side lengths of 6 to 12. So the length of the side of the tiles is between 6 and 12 inches. That's the domain. So the correct answer for the domain would be this one. All right, because the sides of the tiles are, it says here they're whole numbers and they're between 6 and 12. So this would be the correct answer. All right, this is something that looks hard, but if you analyze it, it's actually very simple. They just want us, for each of the given t values, compare a of t and b of t. All right, so a of t is this line right here. It says right here, that's a of t. B of t is this line right here. So when t equals 2, right here there's a little t. T is this line right here. When t equals 2, which one of the two is bigger? B of t, well, when t equals 2, a of t is smaller than b of t because it's below it. When t equals 3 right here, a of t, it's hard to see, but a of t is still smaller. It's still less than b of t. When t equals 4, a of t is above it now. So when t equals 4, a of t is greater than b of t. When t equals 5, a of t is greater than b of t. And when t is greater than 12, like somewhere over here, A of t is greater than B of t. All right, so that's pretty simple. If you take the time to read it, that's pretty simple. All right, there are the answers. Which of the following are the solutions of the equation represented by the graph? Okay, a solution of an equation means which of these points are on this line. That's what that means. So you got to check each point to see if they're located on the graph of this line. Okay, ¿cuál de los siguientes son soluciones de esta ecuación representado por el gráfico? Una solución son los puntos que están encima del gráfico de esa línea. So is -4, +1 on there? -4, +1? No. How about 1, 0? 1, 0 is right here. No. -1, +2, that's right here. No. 2, +4, yes. 0, 1, that's right here, yes. 3, 8, yes, right there. So the bottom three are solutions to the equation of this graph. Okay, it's saying 2, 4 is not on there. Look, you know what? I think I'm gonna leave this in here because 1, 2, 3. I mean, it's very hard to see. I would go with yes. Look, I got this from a review that the district put, and I've already had to stop the video several times because I'm noticing mistakes in their answers, guys. So I know this is hard to see, but as far as I could see, 2, 4 is on there. All right. So as long as you understood what I'm saying, that's all we need for this review. I've already had to take problems out or fix them because there were mistakes in the answers from the district. Who knows who's putting this together? But the important thing is understanding the questions. So yes, this is correct, okay? Algunos de estos problemas tienen errores en la respuesta que ya he tenido que parar el video varias veces para arreglarlo. Pero 2,4 está en esta línea. Okay, in this question it says, which of the following situations describe a quantity that increases by a constant percent that is at least 20% per unit time? Okay, so I want to point out a couple things. It says that it's got to be a constant percent, so it's got to be the same amount every time, and at least 20% per unit time. Alright, so the answers are there, but let me show you how you could figure out which ones are right and which ones are wrong. Okay, the way to figure out is to divide. Like in this one, I'm going to divide 700 by 400 to see what is this being multiplied by to get 700. And then I'm going to do the same thing, divide 1225 by 700 to see are those numbers being multiplied by the same number. So when I divide 700 by 400, I get 1.75. Okay, so 400 times 1.75 gives me this number. And if I multiply 700 times 1.75, I get this number. Okay, that means that the equation for this one is y equals 400 parentheses 1.75 to the t power for time. Okay, so that means that it's growing by 75% every time. Okay, so it's increasing by a constant percent that is at least 20% per unit time. Okay, now again, I just divided 700 by 400 to get that number, 1225 by 700 to get that number. I saw that they're both the same number. If you work out this equation by putting a 1 here, a 2 here, and a 3 here, you'll see that you get these numbers that are here. Now the other one that's correct, all right, if I do the same thing, so 5200 divided by 4000, I get 1.3. Right? So, and if I do 6760 divided by 5200, I also get 1.3. So each one of these is being multiplied by 1.3 to get the next one. If I were to write that as an exponential function, it would look like this. 4000 is my initial amount, and the growth factor here is 1.3. If you substitute a 1, a 2, and a 3 in this function, you'll get these answers. This means that it's growing by 30% each time. Okay, now let's look at the wrong answers. Okay, for this one, if I do 48 divided by 24, I get 2. All right, so this is growing by 200%. But then when I do 72 divided by 48, I get 1.5. So both of these, this one is growing by 200% to become 48%, and then growing by 150% to become. I'm sorry, I said that wrong. It's growing by 100% to become 48, and by 50% to 50% greater to become 72. The problem is that it's got to be a constant percent. I may have said that a little bit wrong, but it's got to be growing by a constant percent. So if every time you divide you're getting a different number, it's not growing by a constant percent. All right, these down here, when you divide it, it's going to be, if I remember, let me see here, 3. Yeah, when you divide this, you get 1.1, which means it's growing by 10%, and it's got to be at least 20%. So that's why this one doesn't work. And the last one, if I divide 11,500 by 10,000, I get 1.15. To be 20% or greater, this would have to be 1.20 or bigger. So that one doesn't work either. All right, almost done with this review part here. I know this is long. Okay, this one's asking about the end behavior of f of x. Okay, what that means, that's talking about the end behavior of the graph of this line, like this way and this way. All right, so let's look at the correct answer so that I can talk about it quickly. Okay, the correct answer says that as x decreases, that means as the line goes this way, because the x value is decreasing in this direction, the value of x, as you go to the left. So as x is decreasing without bound, f of x approaches but never reaches 3. That's the horizontal asymptote. So if we go, that's it. In other words, as we go to the left, x is decreasing, and f of x, which is the y value, it approaches but never reaches 3. F of x approaches but never reaches 3. And in the other direction, to the right, as x increases without bound, f of x, which is the y value, increases without bound. Alright. Así que en lo que x, el valor de x se pone más chiquito yendo para la izquierda, el valor de f de x, que es el valor de y, se acerca pero nunca llega a 3, que es el asymptote. Y en lo que x aumenta, que es cuando va para la derecha, los valores de x aumentan para la derecha, los valores de f de x también aumentan. What type of function best models the given data? If you check by how much they're increasing, by dividing, for example, 562.49 divided by 380, they're all being multiplied by approximately 1.48. Let me check one more. 832.63 divided by 562. Yeah. When you divide any number by its previous number, you'll see that they're all being multiplied by approximately 1.48. When the y values are being multiplied over and over again, that's exponential growth. Okay. Están multiplicando todos los valores por todos los valores de y por aproximadamente 1.48, así que eso es crecimiento exponencial. The domain of this function is given as the following. What is the range? That's easy. You just got to plug in each one of these values for x, work it out, and whatever your answers are, that makes up the set of the range. Okay, all the answers that you get, that's the range of the function. Okay, si este es el dominio, tienen que poner coger cada número que está dentro de este grupo, ponerlo dentro de la función, y cada respuesta que cogen, eso es el rango de la función. I believe that's, yeah. All right, guys, that concludes this review. That concludes this lesson.